Hello everyone, my name is Safa and today I'll be showing you how to look at a molecular formula and spectrums to come up with a proposed structure. We can see that the molecular formula is C10H12O. Given that the molecule has only one oxygen, it is likely an aldehyde, ketone, or alcohol. The CH ratio is very similar, which is indicative of unsaturated carbons, likely from an aromatic structure or just multiple double bonds. Now, we want to look at the degree of unsaturation, which will tell us the number of double bonds in this molecule. The degree of unsaturation for this particular formula can be calculated by multiplying the number of carbons by 2 plus 2, subtracting the number of hydrogens, and dividing this by 2. And when we do this, we get a degree of unsaturation of 5. Okay, so the first graph that we will be looking at is this infrared spectroscopy graph right here, the IR graph. This is going to tell us the functional groups that we have. So yeah, let's take a look and determine those groups. So the first thing I'm looking at is, and also stands out for me, is the lack of an alcohol functional group. So normally alcohol functional groups have a broad peak between the 3200 to the 3500 range. So this eliminates the possibility that we actually have that our molecule is an alcohol. So the only functional groups left is aldehyde and ketone. Aldehydes exhibit characteristic absorptions between the 2700 to 2800 range. However, this is also, this range tends to overlap with sp3 and sp2 CH bonds, making it difficult to distinguish using IR. Yeah, so nonetheless, the strong carbonyl peak that we see here between the 1650 to the 1800 range, right about over here, validates that this proposed structure is an aldehyde or ketone indeed. And then in the fingerprint region, an absorption that stands out is the strong peak between the 690 to the 900 range, right about over here, which is indicative of aromatic CH bonds. So basically, the big takeaways from this IR spectra is that our proposed molecules most likely, contains an aldehyde or ketone, and it is indeed aromatic. Moving on to this C13 carbon NMR right over here. Looking at the spectra from left to right, the first thing that I notice is the peak above the 200 parts per million right over here. So this peak is indicative of an aldehyde or ketone. Additionally, the strong peak between the ranges of 135 to 125 ppm, right around here, around over here, is likely due to an aromatic structure or internal double bonds, in general. The two peaks between the 50 to 10 ppm range are likely from carbons adjacent to ketones and aryl CH bonds, so right over here. Collectively, the CNMR is pointing to a ketone and benzyl in the proposed structure. The signal around the 9 ppm range right here is likely from an alkyl CH bonds. So this CNMR is adding on to the idea that the structure contains alkane CH bonds, aromatic CH bonds, and a ketone. Now for our proton NMR graph we see right here, aldehydes typically have a chemical shift signal between the 10 to 9 ppm range. So the absence, so right over here. So basically the absence of this further points to a ketone functional group instead. The 5H integration signal with a multiplet splitting pattern between the 7 to 7.5 ppm range right over here is likely from aryl hydrogens. The 2H integration signal with a singlet splitting pattern between the 4 to 3.5 ppm range right here is likely from CH bonds adjacent to carbonyls. This carbon is the one between the ketone and benzyl group. Now the signal with a 2H integration and quartet splitting pattern at about 2.5 ppm right here is from the secondary alkyl group on the other side of the ketone. A quartet splitting pattern arises from this carbon having 3 neighboring hydrogens at the end of the molecule. And lastly, the 3H integration signal with the triplet splitting pattern around the 1 ppm range is from the methyl group at the end of the molecule, which has 2 neighboring hydrogens. Overall, in summary, the molecular formula given contains some degree of unsaturation along with an alcohol, ketone, or aldehyde. The IR spectroscopy eliminated the possibility of an alcohol, but it did confirm the presence of a carbonyl and aromatic group. The C13 NMR eliminated the possibility of an aldehyde since the typical signal was not present. The question left was, where would the ketone lie? An aryl group contains 6 carbons and 5 hydrogens, leaving 4 carbons, 7 hydrogens, and 1 oxygen left. This structure is a 1-phenylbutanone, but the H1 NMR showed that there is a carbon between the ketone and aryl group, proving the proposed molecule to be 1-phenyl-2-butanol. So 1-phenyl to butanol. Thank you.